Hello, welcome to the Electron Structure Past Paper Question video. So we're going to look at the question from June 2009. So ionization energies have been used to develop the model of the atom, and this graph shows the different ionization energies. So we need to define the term first ionization energy, and we need to explain why the first ionization energies show a general increase from lithium to neon, and we need to explain the difference between the first ionization energies of lithium and sodium. And we also need to talk about the second ionization energy of oxygen and writing an equation for it. We need to include state symbols, and we need to suggest why the ionization energy of oxygen has a greater value than the first ionization energy of oxygen. So 11 marks, 11 minutes. Come back when you feel that you're finished. Okay. So the definition of first ionization energy is the energy required to remove one electron from 1 mole of gaseous atoms to form 1 plus ions. And explaining why the first ionization energies show a general increase. So the atomic radii decreases and the outer electrons are closer to the nucleus when you remove electrons, and the nuclear charge increases and there's similar electron shielding. So since they're not overcoming the nuclear charge, shielding and distance from the nucleus affect the amount of energy required. And since they're experiencing similar electron shielding, the energy is going to go up and up and up because the nuclear charge is increasing on each of the atoms. And for this one, the atomic radii is increasing and there is more electron shielding. So sodium has a slightly lower ionization energy than lithium. And for the second ionization energy of oxygen, we have O plus gaseous equals O2 plus gaseous plus E minus. And an O plus ion is smaller than an oxygen atom, and electron shielding decreases in an O plus ion. So for this question, electrons are arranged in energy levels. The diagram below for the 7 electrons in a nitrogen atom is incomplete. It shows the 2 electrons in the 1s level. So we need to complete the diagram for the 7 electrons by adding subshell notation and the number of electrons to complete our electron configuration. We need to write out the full electron configuration for the magnesium atom. We need to write the charge of a magnesium ion and a nitride ion. And we need to complete the electron configuration of each ion in magnesium nitride. And finally we need to deduce the formula of magnesium nitride. So okay, we'll go through the answers now. And this is 2p. Also, since these electron shells aren't full, we just write them like that. If it's more than 4 electrons in the orbital, then it will look like this. But for now, since this is a nitrogen atom, then we just leave it like that. And the complete electron configuration of magnesium is 1s2, 2s2, 2p6, and 3s2. The magnesium ion is 2 plus, and the nitride ion is N3 minus. And the magnesium ion is 1s2, 2s2, 2p6 and 3s1, and 2s2, 2p6 for a nitride ion. So the formula is Mg 3 times N twice. Since N is a 3 minus charge and magnesium has a 2 plus charge, you're going to need 3 magnesium atoms and 2 nitrogen atoms in order to make a complete molecule. So for this one, you have a table of the 6 successive ionization energies of an element D, and we need to define the first ionization energy definition and the third ionization energy of element D, and we need to find deduce which of the group of the periodic table contains element D and explain why. So 10 minutes to answer the question, and off we go. So the first ionization energy is the energy required to remove 1 electron from 1 mole of gaseous atoms to form 1 plus ions. And for the equation, D2 plus gaseous equals D3 plus gaseous plus E minus. And I think it's in group 4, and the ionization energy levels jumps between 4 and 5 electrons, and this jump indicates that the element is in group 4. So, okay, it's in group 4 because after the 4th and 5th ionization energy jump, it must drop down to the next shell below the outer shell, as the electrons must be more tightly attracted to the nucleus, and this means it requires more energy than on the outer shell. So that's it for this video. Thank you for watching, and if you want to test yourself, I've got the questions on the document I linked in the video, so if you want to try the questions again, then you can. So thank you for watching, and goodbye.